Here I'm stressing again using the mole-mole factor. Before I had used cross multiplication method. You may use whatever you feel you like and it is easier for you. But both of them, it works the same, but you should understand both ways. Here in this case, I had almost like a formula for you. In order to get it at the end, it will be almost like a one step. I just write, they are asking me 54.6 grams, how much I will get in grams, carbon dioxide. Here we write how much grams of the product in the numerator over the given grams of the reactant, which is 54.6, is equal to the molar mass of the product, 44, which is the carbon dioxide, over the molar mass of the reactant, which is the acetylene, it's 26.0, times coefficient of the product over the coefficient of the reactant. Coefficient of the product, it is 4 carbon dioxide I have. Coefficient of the reactant, it's 2 acetylene. I just find how much grams of the product, I multiply it, 54.6 times 44 over 26 times 4 over 2, and I've got at the end 185 grams of carbon dioxide. By the way, here also I'm stressing about significant figures. Here I have 3 significant figures, 54.6. Here this is 1 mole is exact. Here I have 4 significant. Here 4 moles with 2 moles, it is exact number. I don't consider them as significant. 4 significant 44.01 over 1 mole, it gives me 185 with 3 significant figures at the end, because I have to have the answer, I have to round it to the least number of the measurements as significant figure. Okay, like in summary, here I'm stressing again, no, I have to know both molar masses, and then I have to convert the grams of the given to moles, and whenever I have it to moles the carbon dioxide, I have to convert it to grams using the formula N is equal to mass over molar mass. I have another problem for you in which they are asking me how many grams of oxygen are required to react with 22.5 grams of N-heptane, C7H16. As I told you first, you have to start with a balanced reaction. And then I check how many moles do I have. They are asking me how much do I need oxygen in order to react with grams of N-heptane in order to give me the product carbon dioxide. Okay, I have here 1 mole of N-heptane. I have 11 moles of oxygen. These are the coefficients. Okay, and now 22.5 grams, how much it gives me oxygen? First of all, here I'm using the formula, mass over molar mass. The molar mass of N-heptane, if you go back to the periodic table, you find that carbon is 12, therefore I just multiply 12 times 7 plus 16 times 1. How much it will be? It will be 100.2 gram per mole. Therefore here I have the molar mass, it is for me 100.2. I just substituted. The mass, it is 22.5 grams. I've got it in moles now. Whenever I get it in moles, for every 1 mole, it gives me here, I do need 11 moles of oxygen. 0.225 moles of N-heptane, the one that I got. How much it will be moles here? I do need oxygen. Cross multiplication here. 0.225 times 11 over 1. Therefore, I do need 2.48 moles of oxygen. This moles of oxygen, I'm going to convert it to what? To grams. How do I convert it to grams? I have to use this formula in which it is N is equal to mass over molar mass. How much is the molar mass of oxygen? It's 32. I substituted 32.0. And here they want me the mass for, but I've got it from up the moles of oxygen. 2.48 moles is equal to mass over 32. Then how much it will be mass? 79.4 grams of oxygen. My main concern here, they are asking me if I start with, let me go back to, if I start with 22.5 grams, how much do I need oxygen? The first thing, I should know the molar mass for both, for N-heptane and for oxygen. I just put them beside me. And whenever I have them, I will convert first this 22.5 grams into moles. I will get the moles of oxygen here. How much? Using cross multiplication method. Here I've got it 0.225 moles. How much oxygen moles? But therefore I just multiply this times 11 over 1. I've got 2.48 moles of oxygen. Whenever I've got it in as moles, I may convert this one to grams using the formula, this. Of course, I should know the molar mass. I just write it. I've got the mass in grams. It's 79.4 grams of oxygen. Here I have also another problem. How many grams of potassium are required to produce 36 grams of KCl? Okay. Therefore, here, the given as a product, 36.0 grams of KCl. How much do I need grams of potassium in order to get 36.0 grams? Look here, I do have this in red. 2 moles of potassium, it gives me 2 moles of potassium chloride. I have to know the 2 molar masses of K and KCl. I have to determine the number of moles, and then I calculate the mass of K needed. Okay, here I do have the reaction it had taken place. It's balanced. 2 moles of K, it gives me 2 moles of KCl. How much do I need from K to get 36 grams? The molar mass of K is 39.10 gram. The molar mass of KCl is 74.55 gram per mole. Here, what do? I have to convert in such a way the grams to moles, 36 grams. I want to convert it to moles. I know that for every 2 moles of potassium, K, it gives me 2 moles of KCl. Therefore here, if I get 0.483 moles, how much I will get potassium? If I just multiply, it will be the same. Here I have another problem for you, in which I have potassium plus chlorine, it gives me potassium chloride. This is a balanced reaction. In such a way, I have 2 moles of potassium, it gives me 2 moles of potassium chloride. Here they are asking me if I've got this grams of potassium chloride in the product, how much did I start grams of potassium? Therefore, the given is the product, whereas the need in grams of potassium, it is the reactant. Okay, as already you know that, I have to know both molar mass. At the same time, whatever I have it in grams, I have to convert it to moles. And I use the formula N is equal to mass over molar mass. Let me do it, me and you. Here, I have the molar mass of potassium is 39.10 gram per mole. Molar mass of potassium chloride, 74.55 gram per mole. the product in grams, 36 grams, KCl. And here, how much I started with in potassium. The coefficient for every 2 moles of potassium, it gives me 2 moles of KCl. Okay, and therefore here, what do? I have to convert the grams of KCl into moles. Yes? I know that for every 2 moles of potassium, it gives me 2 moles of KCl. Okay, how do I convert these grams into moles? I use the formula, which is N of KCl, number of moles of KCl, is equal to mass of KCl over molar mass of KCl. The mass of KCl, 36.0 gram, over molar mass of KCl is 74.55. It gives me this moles of KCl. Therefore, I go back to the coefficient and check. 2 moles of K, it gives me 2 moles of KCl. This moles of KCl that I had got it as a product, how much did I start? It is the same, because already 2 moles, 2 moles. This much I've got 0.483, therefore I should have started with 0.483 moles. What do? I have now to, I've got this in moles, 0.483. I have to convert it now to grams. How do I convert it to grams? I use this formula, 0.483 over molar mass, here, 0.483 moles, this one, number of moles, times molar mass, 39.1, I will get 18.9 grams. Therefore, I should have started with 18.9 grams of potassium in order to get 36 grams of KCl. I hope that you understood this problem, and always you have to check and calculate for molar mass for both, and check what do you need, and always you have to use the N is equal to mass over molar mass to convert it using this formula. Here I'm just stressing again this problem in such a way, I'm stressing that you should get the molar mass of each. At the same time, if you want to use the mole factor, look what I had done for you here. You may write it as grams of the reactant, the unknown, you don't know it, this one, over the given grams of the product, in which it's 36, is equal to the molar mass of the reactant, it's 39.10, over the molar mass of the product, which is 74.55 gram per mole, times the coefficient of the reactant, which is here 2, over the coefficient of the product, which is 2. And at the end, you will get 18.9 grams of potassium. You may use this one in such a way, it is as a one-step method. Thank you so much. I hope that you understood this lecture, and I hope you always go and practice the problem so well. Thank you.